Okay, we're going to wrap up the measuring economic exposure videos with looking at these next two cases. The second case is a kind of a strange case because of the nature of the exchange rate and how it relates to the value of the asset in local currency. So in this case, we have the local price or the local value of the asset varying inversely with the exchange rate. So if you look here, we've got the value of the asset the highest in the worst state. The exchange rate is the lowest in that state. Then you have the kind of the middle ground, and then in state C, whatever that is, maybe it's the expansion state, the value of the asset is the lowest and the exchange rate is the highest. In any event, the value of our asset in dollar terms is invariant, right? It doesn't matter which state you're in because the peculiar nature of these, the relationship between the spot price and the value of the asset. Now this is kind of a contrived example, but if you look at the measurement here, we've got the covariance, the variance, and the beta. The beta is 0. It means that there's no exchange rate risk that we're dealing with. So if you found yourself in a world where there's the behavior of the assets and the exchange rates is like this, there's nothing to really do because it's kind of naturally hedged by virtue of the relationship between the price of the asset and the exchange rates. Now, a slightly less contrived version is this case 3 here. And this is where the local price is invariant to the exchange rate, right? There's no relationship whatsoever between them. And so you can see the value of the asset is the same in all states, but the exchange rate is varying depending on which state of the economy you find yourself in. And so because the exchange rate is varying, the value of the asset in dollar terms is also varying. We can do the same calculation, find out the covariance of the spot rate with the dollar value of the asset, divide that by the variance of the exchange rate, and that gives us this beta coefficient. In this case, it's 1,000. That tells us how much we should hedge. And if we go over here and we hedge 1,000 pounds, we sell it for it at a rate of $1.50. We kind of go through the calculation we did in the other video where we see this is basically the same information that's captured over here. But now if we layer on the forward contract, we have some dollar value implications from that hedging. And so what happens is when we stick in the hedging, we end up in a situation where we have $1,500 in value no matter what state of the economy that we're in. And in this case, you've completely eliminated the exchange rate risk because this value right here is invariant to exchange rates. So again, entering into the hedge gets rid of it all. Up here, getting into the hedging arrangement gets rid of the vast majority of that. I'm not sure what the percentage is, like 98% of the variance is reduced by virtue of us going into the hedge. It's not perfect, but we're drastically reduced the risk of an adverse outcome. So that is the idea of measuring it. That's the reason that we would do a beta, and how we would use the beta that we come up with from measuring the exchange rate risk. Boy, this is a really quick video. So this is probably going to take a little bit of time to digest. So I would suggest you open up this spreadsheet that's in the Canvas and kind of work through what's going on with each of these measures, what you're hedging, what you're measuring in terms of covariance, in terms of variance. Look at the example in the book. I think it's very much like this actually. And that'll give you a better sense of what's going on here. So you can handle any conceptual questions that might come along and any computational questions that you might have in terms of a homework, a quiz, or a test question. So that is all of measuring economic exposure. That's all of the Chapter 9 videos that we have. And I will see you in the next topic videos. Bye-bye.